What's up, you math maniacs? Here we go. This is section 4.4, day 2. More theorems about zeros and polynomial functions. So this is the rational zeros theorem. Basically, we're going to take a polynomial function that has coefficients integers. Like of all these a's are integers. And then you're going to be able to say that you've got only a limited number of possibilities for what the zeros could be, for what the rational zeros could be. So, for example, I'm going to fast forward to the very end, and the zeros of this problem are, some of them are rational and some of them are not. But here we've got an integer, and we've got rational, and this is an irrational number. Well, all the rationals and integers can be expressed with this fraction. You take the last number, the last coefficient, it's just, for us it's -4, and you take all of its factors, 1, 2, and 4, and then you take the first one, and you put it in the denominator of the same fraction, and all of its factors, and then what you get is all the possibilities for p and q. So basically, all the possibilities for the rational zeros would be plus or minus 1, plus or minus 2, plus or minus 4, and then every possible fraction you could make, 1/3, 2/3, 4/3. That might not sound like a big deal, but what it means is that you're not going to be going on forever trying to figure out what the zeros are. In fact, I graphed this on Desmos, put this in and I graphed it, and then I got 4 different zeros. Not knowing what they are down at the bottom, I can see that one of them is -1. I can see that another one is 2/3, and I got 2 others that I have no idea what they are. Well, if it's rational, then it should come up in this list right here. So I'm going to try -1. This list is really important if you, for example, don't have access to a graphing calculator. But even if you do, it's helpful because I know that -1 is going to work, and I know that 2/3 is going to work here. And so what I did was, in order to figure out the rest of it, you've got to take the polynomial and divide it by x plus 1, or the 0 minus 1. Notice one little thing that sometimes trips up people is that we've got negative x cubed, negative 11x cubed plus 10x. So the -11 is here and the 10 is here, and in between them is the quadratic 0. So it's a 0x squared, which is right here. Anyway, I'm going to divide it by -1, and so I add, multiply by -1, add, multiply by -1, add, multiply by -1, add, multiply by -1, add, we get 0. So what I'm left with is the dividend 3, -14, 14, -4. I'm going to take my other rational 0, which is 2/3, and I'm going to divide it by 2/3. So we add, multiply by 2/3, add, multiply by 2/3, add, multiply by 2/3, add. What I'm left with is here, the -1, remember, becomes x plus 1, and 2/3 becomes x minus 2/3. And I'm left with this 3, -12, 6. 3, -12, 6. I'm going to factor out the 3, and eventually the 3 is going to go here. 3 times x minus 2/3 is just 3x minus 2. Just to make things easier over here, I'm going to factor out the 3, and then it happens to cancel out the fraction here, so that's a good thing. Anyway, I'm left with x squared minus 4x plus 2, and I'm going to plug the coefficients into the quadratic formula. A is 1, b is -4, c is 2, and the quadratic formula spits out the last 2 roots, 2 plus square root of 2 and 2 minus square root of 2. So those are the zeros, and the factors are x minus that and x minus that. Anyway, I've got my zeros and I've got my factors, and I'm done. This is written in factored form, and these are the zeros. And if you calculate out what 2 plus square root of 2 is and 2 minus square root of 2, you actually do get these numbers anyway. So you might ask yourself, Bergman, hold on. You mean, what if I just went from here and then all the way down to here with these 4 numbers. Well, you could do that if you had access to a graphing calculator, but you wouldn't know that this is exactly 2 plus square root of 2, which is kind of a big deal sometimes, and 2 minus square root of 2. These are exact numbers, and these are just approximations. So you wouldn't know that, and then, of course, this is a process that you might not always have a graphing calculator with, so you have to make sure you can do it with or without graphing calculators. On top of that, it helps us understand the features of the graph better to do it by hand. Okay, so here, I'll just leave the whole thing so that you can see it. I've got this function, and I want to find the zeros and the factors. Okay, so I'm taking 15 and all of its factors and putting in the numerator, and then 2 and all of its factors and putting in the denominator. I also graph it, and I see 3 different zeros. I'm going to expect 5 of them, but I only see 3. And only one of them is going to be rational, and that's 1/2. Good. Well, I expected 1/2 to be a possibility, and here it is. So I'm going to take all those coefficients and divide out 1/2 as the 0. So add 1/2, multiply by 1/2, add, multiply by 1/2, add, multiply by 1/2, add, multiply by 1/2, add, multiply by 1/2, add. Remainder 0, so it worked. I get 2, 0, negative 4, 0, negative 30. 2, nothing here, negative 4, nothing here, negative 30. And the 1/2 goes right here. So you can see what I did next is I factored out the 2. The greatest common factor is 2. And I'll bring it over to this side to cancel out the fraction. And it becomes 2x minus 1. Then I've got this x squared, x to the 4th minus 2x squared minus 15. I'm going to do a u substitution. U is equal to x squared, so u squared is equal to x to the 4th. And then it becomes a lot easier to factor u squared minus 2u minus 15. Well, what 2 numbers add up to negative 2 and multiply up to negative 15? Negative 5 and 3. Put them here and back substitute back into the x squared instead of u's. Next, I've got a squared minus b squared factors into a minus b and a plus b, and that actually works out here also. X squared plus 3, you can think of it as x squared minus negative 3. The square root of negative 3 is square root of 3i, square root of 3i. Anyway, here is the polynomial in factored form. Notice only 3 of them are real numbers, so that's why we only get 3 x-intercepts in the graph. The other 2 are imaginary. And here are the zeros. 1/2 plus or minus square root of 5 and plus or minus square root of 3i. Here's another example, 55. I think that x plus 3 is going to be a factor, and I'm getting that because I see x plus 3 and then 2x and 6. And so actually, I had a hunch that grouping would work for this as a factor, and it does. You could similarly do the polynomial division with x with a 0 of negative 3. But here I'm just going to choose the grouping method, and it works just fine. So what is the greatest common factor of x of these first 2 terms? It's x squared. And x squared times what gives me x cubed? That's x. X squared times what gives me 3x squared? That's 3. So we get x plus 3 here. Then I'm going to find the greatest common factor of these 2 terms. That's negative 2. I'm going to factor out a negative 2 times what is minus 2x? That's x. Minus 2 times what is minus 6? That's positive 3. And now I've got these 2 x plus 3's, and I combine them into 1 right here. X plus 3. Taking the coefficients on of both of these terms and grouping them into 1, you get x squared minus 2. So it becomes a squared minus b squared, a minus b times a plus b, and the x minus 3 comes down also. I'm left with 3 zeros, plus or minus the square root of 2, and negative 3. Here is the original polynomial. I'm going to graph it and I see that I've got, although I'm expecting 4 zeros, 1, 2, 3, 4, I've got 2 of them right here, 1, 2. Those are the real ones, and I can see they're also rationals. So this is going to be -1, and this one's going to be 1/3. When I write the coefficients, I get this. I'm going to add, multiply by -1, add, multiply by the 0, add, multiply by the 0, which is -1, add, multiply by the 0, which is -1, add. I get 0. Great. So -1 is, in fact, a 0, which I knew. Then I'm going to take this, I'm going to divide out 1/3. I'm going to add, multiply by 1/3, add, multiply by 1/3, add, multiply by 1/3, add, we get 0. 3, -6, 6, which is what I get right here. The 2 zeros come down as factors, and I can even factor out 3, the greatest common factor, which is 3 from each of the 3 terms. And there it is. And I'm actually going to multiply it over here to cancel out the fraction. It just becomes 3x minus 1. Anyway, I'm left with x squared minus 2x plus 2, which I can plug into the quadratic formula, especially if I'm living in Kathmandu, Nepal. That's where my friends live. They lived there for a year teaching English to Tibetan monks. It was pretty awesome. They got some great photos. I've never been there, but if you've been there, then maybe you can tell me, as they did, how chill of a place it is up in those mountains. Anyway, you can figure out what the remaining 2 zeros are by plugging them in the quadratic formula. And then after you do that, you can start assignment 4D2. Copy the problem list and do the first problem, and I will see you in class.